Hi, welcome to today's lesson on zero and negative exponents. We're going to be doing an extension of our last lesson, which was division with exponents. We did multiplying with exponents, and we did one on dividing with exponents, and this is just kind of an extension of that. Really, it is. Because students really don't understand negative exponents. They want to make negative exponents represent negative numbers. And the truth is that negative exponents have nothing to do with the sign of the number. Okay, so if you remember back to the last video, I asked you this problem. I said, we're just going to simplify x squared divided by x to the fifth. And we're going to look at it two ways because that's what's going to make this make sense. Okay, if we utilize the method that we learned in our last lesson, which is that when we're dividing by with exponents, we can simplify by subtracting the exponents provided the bases are the same, which they are going to be in pretty much every one of these things that we do. So we take our x to the second, and then we can subtract the 5, and that's going to get us a negative 3. Now the question is, what does that negative 3 really mean to us? What does it represent? What it means to us is this. If we were to simplify it by writing it out, and if you remember back to the previous video, that was one of my big suggestions, was when in doubt, write it out. That I can reduce this x, and x divided by x is 1. Anything divided by itself is 1. And that's actually going to come up again a little bit later on when we talk about a zero exponent. We can reduce this x and this x, which again gives us a 1. 1 times 1 is 1, and then 1 times 1 is 1 times x times x times x, or x to the third. So this negative 3 is telling us that what we had was more x's in the denominator than in the numerator. Okay? All a negative exponent is, and here's the big definition, okay, a negative exponent is the reciprocal of the positive. Okay, and we're going to see that a couple of different ways. Okay, it doesn't just mean in the denominator, it means it's the reciprocal. So that matters when, if the negative exponent, for example, was in the denominator, it would mean something I'll show you in just a minute. But this is the definition. A negative exponent is the reciprocal, which for those of you that maybe haven't thought about it for a while, just means flipped over. Okay, so if it's in the denominator, if it's in the numerator like this one is, then it becomes positive in the denominator and vice versa. Okay? It does not mean negative numbers. It doesn't make x negative. If these were 2's, for example, it would not make it negative 2. Okay? Negative exponents do not make negative numbers. They make reciprocals. Most of the time they make fractions. Okay? So here we had a negative exponent in the numerator. We could have made this a fraction. Becomes the denominator. How would that have looked if we'd gone the other direction? If we'd had a negative in the denominator. So let's take a look at that. And for some of you, you may be noticing that, hey, I'm not wearing my bionic arm. I've gotten out of my cast. I'm still not there yet, but much better than I was maybe 3 videos ago. Okay, so what if we had something that looks like this with the negative exponent in the denominator? How would that be different than the one that I just showed you? Well, the definition is that it's the reciprocal. So if we were to just flip it over, and then it would become the positive. That's what it is. Now why? Okay, let's be thorough on this. Because originally this would be 1 divided by, that's the fraction, 1 divided by x to the negative second. Well, x to the negative second by itself absolutely means 1 over x to the positive second. That's what it means. When we divide by a fraction, we don't. We actually multiply by its reciprocal. And that, as you can see, is how we're going to get back up here to x. So if the negative exponent is in the numerator, it goes down to the denominator and becomes positive. If it's negative in the denominator, it will go up to the numerator and become positive. So really, it just moves, just goes up or down, because it's flipping and becoming positive. So if one's positive, one's negative, it flips. So if we had a fraction, so let's take this, and again, we would ask us to simplify. Well, the negative exponent says flip it. We're going to flip the whole fraction. And then we make the exponent positive. Positive says, hey, we're going to multiply what's inside the parentheses twice. 3 times 3 is 9. 2 times 2 is 4. And I'd leave it as a fraction. Improper fractions are fine. I would never bother to reduce them. I certainly wouldn't turn them into decimals. Decimals would get very confusing when you go from a fraction to a decimal, when you're doing all this stuff where you're moving between numerator and denominator. I don't think that's a good idea. I think it's best to just leave them as fractions. Okay? But now I want to talk about my favorite of the exponents. What's 0 as an exponent? What does that even mean? Okay? And it's confusing at times, but it's so easy. Okay? So, what is 0 exponent? So let's call it 5 to the power of 0. What is that? Well, here we go. Anything, and I do mean anything. Okay? Variable, weird number, irrational number, doesn't even matter number. Anything, positive, negative, irrational, rational, imaginary, anything you can think of. Numbers that don't even exist. Anything to the power of 0 equals, drum roll please, 1. Doesn't matter what it is. It's weird to say that, but it does not. And I'll show you what I mean. So here, if we had a problem that said simplify 4 to the third divided by 4 to the third. Seems simple. I mean, right away you can see these are exactly the same thing, and anything divided by itself is 1. If we were to write it out, because we're still in doubt, 4 divided by 4 is certainly 1. 4 divided by 4 is certainly 1. And 4 divided by 4 is certainly 1. If I subtract the exponents, I get 4 to the power of 0. I could even take that off. I could take off the 4's. What if I did it with x's, unknowns? How does it change? It doesn't. Doesn't matter. Does x not knowing what the number is make any difference? Because eventually, because I'm going to still have the same situation. And x divided by x is still going to be 1, because anything divided by itself is 1. Even if I don't know what x is, it's still dividing by itself. It's a number dividing by itself. It's going to be 1 every single time, no exceptions. So anything to the power of 0 equals 1. That could be negatives. What if x was negative 5? It wouldn't have changed anything. We'd still have the same result. Okay? You ever just want to be in doubt, try it on a calculator. You know, just type random stuff in and then hit, the power button, which is the Y, it looks like this. Y to the X looks like that. And then you put in a 0 and watch, it'll just keep giving you 1 no matter whatever you type in. You could hit you could hit 20 buttons in between. If you then say exponent 0, it'll go, whoop, here's your 1. And it's always positive 1. It's never negative. So even if your bases are negative, you still get a positive 1, because if if x's were negative, a negative divided by a negative, 2 negatives make a positive. So you're still going to get a positive 1 every time, no exception. It's always going to work that way. Okay? And it's weird, but it's cool. It's because it's just easy, and they love to see if you know it. And it's one of those you kind of have to know it, because there's no math for you to do. If they hand you 5 to the power of 0, what are you going to do? There's nothing for you to do. Okay? Technically, it's like you go 1 times, and then you just kind of float out into the ether. But really, it's just anything to the power of 0 is always going to be 1. Okay? Now, one of the things that makes this section a little more challenging, I mean, as if negative exponents weren't enough, okay, is when they give you something where it seems like everything's got the exponent, but it doesn't. Like, and sometimes they'll even tell you, write the answer with only positive exponents. And this is something that comes up again. I used to say Algebra 2, but we don't have that anymore. So I guess that's now Integrated Math 3, maybe? Integrated Math 2? I don't know where it falls anymore. But they give you something that looks like this, and it seems so simple. 2x to the negative third. But we got to remind ourselves of the order of operations, because that's one of the things that drives where things end up. Remember, a number next to a letter means to multiply. So if I write it out with the multiplication symbol, maybe that makes it a little clearer. Because when we're multiplying, right, exponents still come first. Parentheses, then exponent. So I have to deal with this all by itself first. Well, we know that it means it's the reciprocal of the positive exponent. So we're going to make it go from a negative exponent to a positive exponent. We can always make this into a fraction if we need to, and now we can do it. Simplify it. 2 times 1 is 2 in the numerator, and 1 times x to the third is simply 1x to the third, or just x to the third, in the denominator. So it's very tempting to make this all end up in the denominator, but you have to remind yourself because of the order of operations which one comes first. Now, if I wanted that to happen, I would write it like this, 2x, and then I'd put that in a parentheses, and that whole thing would be to the negative third. Now I can apply the exponent to everything in the parentheses. So I can now rewrite this as 1 over 2x, parentheses, to the positive 3. So this would be 1 over 2x times 2x times 2x. 2 times 2 is 4, times 2 is 8, and x to the, still 3 of them, x to the third. So they're very different if they have the parentheses around the whole thing or not. And that's, again, that's what parentheses are for in the order of operations. It's a way of telling you, hey, deal with this first. Okay? So you need to make sure you're always careful, because it's very tempting to take this and turn it into this, but it's not. Okay? Because the order tells me to do the exponent first there, while here the parentheses tells me to do it first. Then apply the exponent to everything inside the parentheses. Okay? So I think we're actually getting through this a little faster than I had anticipated, and that's okay. So let's do a little quick recap, and we'll be done here. Okay? So the simple, anything to the power of 0 is 1. Okay? Now let's talk about negative exponents. Negative exponents are the reciprocal of the positive exponent. Okay? So just flip it over, move it from numerator to denominator, or vice versa, from denominator to numerator. Okay? One of the ones I've seen on homeworks and worksheets, they love to give you, like, and I think I'll just throw this one at you and we'll be kind of done here. And again, it's always simplify if we have variables. And they'll say something like, how about 2x to the negative second over 3x, not x, let's make it a different variable, y to the negative third. Well, write it with the multiplication, so I'm reminding myself that I'm dealing with the exponents first. So this one tells me to put it down here to make it positive. And this one is telling me to move it up here to make it positive. So notice the 2 and the 3 aren't changing places. Just the y and the x. That would be writing it with only positive exponents. And usually when they're asking you to simplify, they want positive exponents. You don't really need them, but they like them. That's what they want you to do with them, is to move them and make them positive. So again, numerator goes to denominator, denominator goes to numerator. Okay? Again, not making negative numbers. Okay? That's one of the things that just, I always ask the question at the beginning of the class, and usually no student has seen this before and knows what to do. If you give them something as simple as, again, simplify, even though we're going to solve it, oh, let's just go 2 to the negative third power. We just saw it a second ago. That means 1 over 2 to the positive third, which is 1 over 2 times 2 times 2, which is 1/8. No negative, not a negative 1/8, but a positive 1/8. So even though we have a negative exponent, we don't get a negative number. Now, if the base was a negative, so I guess I got one more thing to show you. If the base were negative, and I'm going to have, in order for it to be negative, it needs to be in a parentheses. If the negative sign were in the front with no parentheses, it would just be at the end. Here, I have 1 over negative 2 to the third, which is 1 over negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is positive 4 times negative 2 would be negative 8. Notice I put the negative sign in the numerator. We always do that just because of the English language. The number is negative 1/8. Negative is the adjective describing the number 1/8, so it goes first. So I always put it in the numerator. It's not 1 negative 8ths. It doesn't make sense to say it like that. It's a lot like saying, you know, I have a blue bathroom. That's fine. Would I say I have a bath blue room? I would not do that. So I would never break up a fraction to tell you to put an adjective of negative in there. Okay, so that's the only time you even get a negative number is if the exponent is odd. If it were even, we'd end up with a positive every time. So the only way you can get a negative with exponents is if the base is negative and the exponent is odd. Okay, but it has nothing to do with negative exponents. They just give you the reciprocal. Okay. All right, lot to take in. I hope this was helpful, and I will see you in class or in office.